OCR, or optical character recognition, is a technology that converts images or scanned documents into editable text. Here's how it works. I'll input a file from Dropbox. It's a standard invoice template I found online. Then I'll send it to an OCR service. For this example, I'll be using LlamaIndex. We upload the file to the service, wait for it to be processed, and once it's ready, we download the result. The processed result comes back as markdown text, which is now ready to be used. From there, depending on the task, I convert it into HTML to make it readable, and then you can save it as a PDF or a text document. Alternatively, using AI and a predefined template, I can extract specific information for further processing or to populate a spreadsheet, such as items, their names, quantities, and prices. Then, we can either continue processing this information further, or, in this case, I'll simply write it to a Google Sheet. Here's what it looks like after it's been recorded. In this part of the workflow, I've intentionally incorporated several different online services, specifically Dropbox, LlamaIndex, and OpenRouter, which connects to OpenAI's ChatGPT model. Finally, all of this is recorded in a Google Sheet. However, this setup might not align with your company's privacy policy, or if your documents contain trade secrets. So, as an alternative, I've also developed a local version that processes all information without involving third-party services or uploading any data to the internet. This same file, for instance, can be read directly from disk. Alternatively, it could be sourced from an FTP server or your local storage. All of this is processed by a local OCR service called Docling, which processes the document and returns the text in Markdown format. Next, we process it with the same information extractor, but in this scenario, we're using a local AI model. Finally, we save all of this to a local database, which in this example is NocoDB. And here's what the recorded result looks like. In next workflow, we'll explore how to work with resumes. I've prepared various file formats, and all these resumes contain different text content. It would be impractical to manage them as individual files. So, the goal of this workflow is to structure this data, categorize it, and then store it in a database. Docling processes the document and extracts Markdown. Then, using the information extractor, we extract the necessary fields and structure the data we need. Let's also assume we have hundreds or thousands of such candidates. To streamline the HR department's work, we can pre-process this data. For instance, to demonstrate this processing, we'll also input a job vacancy. Our AI agent will help us with this. It takes both the job posting and the resume as input. We've configured the system prompt to analyze the candidate's resume against the job posting and assign a score from 0 to 10, indicating how well they fit the role. It also needs to explain why the candidate received that particular score. We record the results in a database, obtaining structured data that's easy to work with and store. Even though all resumes were different, the data is neatly organized into its respective columns. And if certain data isn't present in the input document, we'll simply get an empty field. Naturally, this can apply to any type of document, not just resumes, but the underlying principle remains the same. Let's look at a slightly more advanced scenario where we need to extract not only text, but also photos from a document. For this example, I'm using an instruction manual for a charging station. We'll use the result as a knowledge base for an AI agent. Ultimately, we'll store all of this in a vector database. Docling can separate text and images. One process extracts the text, providing it in Markdown format with tables, while a separate process handles the photo extraction. These photos are then saved to local storage. Here, I'm using min.io storage. Here's what the extracted photos look like. Alternatively, you could use online storage options like Cloudflare or Amazon. Additionally, the Llama visual model generates brief descriptions for each photo. This provides context, helping the AI agent understand what's in the images and allowing it to return them as part of a response when relevant. Next, I break all of this into chunks, preparing it for storage in the vector database. Then, we save it all to Quadrant. In the next episode, we'll explore how to work with vector databases and build RAG systems. I'll show how combining AI with your own knowledge base lets you create bots that can answer questions, assist customers, or even act as digital sales agents. Subscribe and turn on notifications so you don't miss it.